So I'm going to be talking about the first derivative test today. So there are 6 steps into doing the first derivative test. So in my handy dandy study guide, I don't know if you'll be able to see it, but the first step is to take the first derivative. Second step is to find the critical point, which is setting f prime equal to 0 or does not exist. Third step is to set the intervals, which is drawing a number line and plotting the critical points onto the number line. Number 4 is to pick a test value on each interval. Fifth step is to test the values in f prime to determine the signs. And then once you determine the signs, we can see if it is a min, max, or neither. So I'm going to do an example of the first derivative test following the steps. So the equation I'm going to be using is f of x is equal to x squared minus 1 cubed. So doing the first step, which is taking the first derivative. So the first derivative is, we are going to do the chain rule. So it is going to be 3 times x squared minus 1 squared times 2x. So to simplify that, that is going to be 6x. Yeah. And our second step is to find the critical points, which is setting f of x equal to 0. So we're going to set this equal to 0. And 6x is, that is going to be 0. And then setting this equal to 0, we're only going to set the inside equal to 0. So x squared minus 1 equal to 0 is also x plus 1 times x minus 1 is equal to 0. So our critical points are going to be x is equal to 0 and x is equal to negative 1 and 1. So now that we have our points, we are going to plug that into a number line. So negative 1, 0, 1. And now what we're going to do is plug numbers from these intervals into f prime. So any number to the left of negative 1, so negative 2, we're going to plug that into f prime. So 6 times negative 2 squared minus 1 squared. This is going to be negative, and we know that this is going to be 3 squared, so we don't even have to solve it out. We know that a negative times a positive is going to be a negative. So that interval is negative. Okay, so moving on, a number between negative 1 and 0 can be negative 1/2. So 6 times negative 1/2, and 1/2 squared minus 1. So we know that this is negative 3, and this is going to be positive minus 1, even though it is going to end up negative. A negative squared is going to end up positive. So this is going to be a positive number, so this is still going to be negative. So the numbers between negative 1 and 0 are going to be negative. So at 0 to 1, we can use positive 1/2. So 6 times 1/2, 1/2 squared minus 1 squared. So this is 3. Again, even though it's negative, when you square it, a negative, it's still going to be positive. So positive times positive is positive. So the interval between 0 and 1 is positive, or increasing. And then we know that 2, we can plug 2 in. So 6 times 2, 2 squared minus 1 squared, so 12, 3 squared, that is positive. So in order to do our last step, which is determining if it is a maximum, a minimum, or neither, so we have to look at our interval here, and determining if there is a max or min, we have to look at the signs. So wherever the sign is changing, that is where we are going to have a max or min. So we can see at 0, oops, I just totally drew over that. There is a sign change from negative to positive. So our graph is going to look like this. So it's going from negative to positive. So this has a minimum. So we know we can say that at x is equal to 0, f of x has a local minimum, and if we want to find a specific point, so like what is the y value when x is equal to 0, we are going to plug in 0 back into the original equation, which is f of x is equal to x squared minus 1 cubed. So 0 squared minus 1 cubed, that is going to be negative 1 cubed, which is equal to negative 1. So our answer is at x is equal to 0, f of x has a local minimum at 0, negative 1. That is the answer.